Hi class, welcome back to my YouTube channel, and for today we are going to discuss the subject Business Mathematics, and the lesson we have is the lesson 3, which is about the kinds of proportions and its examples in real life situations. But first, let's have our objectives for today's discussion. Of course, first, the learner should be able to identify the different kinds of proportions and, of course, write examples of real-life situations for each kind of proportion. Okay, let's start. Let us define the term ratio. So what is a ratio? So it is a comparison of two quantities or two value by division. So we are using the operation division in ratio, which these two quantities is always expressed in the same unit of measure. So when we are using unit of peso for the first value, so we need to quantify it or to compare it to another quantity, which is a peso also. So when we have the division of that two quantities or two values, we have the ratio. So the ratio can be denoted into two forms. So we have first this A is to B. So the symbol is colon. So this notation is called adds notation. So it is again read as A is to B. And next one we have A over B, or also can be read as A is to B, but it is in fractional notation. So of course in fraction form, we need to make sure that our B or the denominator should not be equals to 0. Why? Because fraction which has a denominator of 0 is indefinite or infinity. So we have a special type of ratio. So that is called the rate. So the rate is somehow can be represented into percentage. So that is a special type of ratio. So we have percentage, similar to percentage. So we have a statement when there are two ratios that are equal or equivalent. If there are two ratios that are equal or equivalent, meaning they have the same value. So let's have examples. First, let's have this fractional fraction or the ratio. First, we have 20 over 16. So 20 over 16, this ratio is also the same to 5 over 4. Because when we divide 20 over 16 to a value 4 over 4, so we will have a value 5 over 4, meaning the 20 over 6, the 5 over 4 is the lowest term or the reduced form of 20 over 16. So they have the same value. Because 4 over 4 is just 1. When we divide it to 1, so it's the value that you divide to 1, it's still the same value itself. Let's have another example. So 35 is to 100 is has the same value with 70 is to 20. Why? When we divide 35 to 5, we have equals to 7. So we have 7 there. And when we divide 100 to 5, we have equivalent of 20. So this 35 is to 100 is just the same to 7 is to 20.
Let us have our first example in ratio. So we have here 3, the A, B, and C. So first, in this example, we need to write these ratios in their simplest form. So first we have 2 over 5 or 2/5 is to 1 over 4 or 1/4. So to get the simplified form of this ratio, which is in the form of fraction and in odd notation, so we need to get the LCM of both fractions 2 over 5 and 1/4. So the least common multiple or the LCM is in this with these fractions is, so we have 5 here for our first denominator and 4, so our LCM will be a product of the two. So we have 5 times 1 is 20. So let's multiply the LCM to both fractions. So we have 20 multiplied by 2 over 5 is 2. 20 multiplied by 1 over 4. So 20 times 2, that is 40 over 5 is 2. 20 times 1, that is 20 over 4, that is 20 over 4. So we have 40 divided 5, that is equals to 8, is 2. 20 divided 4, that is equals to 5. So our simplest form or the simplified form of this ratio is 8 is to 5. So there is this another solution or another process to get the simplified simplest form of this ratio. So we can just let's write 2/5 is to 1/4. So we can just cross multiply these two fractions. So we have 2 times 4, that is 8 is 2. So 5 times 1, that is 5. So we have the same answer, which is 8 is to 5. Next, let's have this letter B. 1 and 1/6 is to 4 over 5 or 4/5. So we have here a mixed fraction called so this is a proper. Then when we have a numerator greater than to your denominator, we have your improper fraction. So this is a mixed fraction. Let's transpose or convert it to an improper fraction. So we have 1, which has a denominator which involves 1 over 6. So we have 6 over 6 here plus 1/6 is to 4/5. So 6 plus 1, so since they have same denominator, so I'll just copy the denominator, then 6 plus 1, that is 7, is to 4 over 5. So to get our simplified form, we can just use cross multiplication. So let's multiply 7 multiplied by 5 is to 4 times 6. So we have 7 times 5, that is 35, is to 4 times 6, that is equals to 24. So are there any values? So this 2 has a GCF of 1, so that is the goal. So now that is, since we don't since our GCF is 1, so this is the simplified form of our ratio. And last example, we have 0.08 is to 0.14. So this time we have a given in decimal form. So we need to write its equivalent form without the decimal. Then of course we need to simplify. So since we have decimal, we can multiply both. 2. So let's write it in fractional notation. So we have 0.08 divide 0.14. So we can multiply both numerator and denominator or your the ratio in 100 by 100. So 0.08 multiplied by 100, we have equals to 8. 0.14 multiplied by 100, we have 14. So we have here a fraction 8 over 14 or 8 is to 14. So let's get the simplified form of 8 over 14 rather. So what is thing that we can divide to get the similar form or their LCM? So we can divide to our numerator a value of 2. You can also divide a value of 2 to your denominator. So 2 divided 2, that is equals to 1. So it's just the same. Of course, we're just simplifying or reducing this ratio. So 8 divided by 2, that is equals to 4, and 14 divided by 2, that is equals to 7. So our ratio is 4 is to 7, or in odd notation, we have 4 is to 7. So this is our simplest form for 0.08 is to 0.14. So let's have our second example problem. Cassie and Marga are both candidates for Miss Shelita Zamora Senior High School. Cassie received 5,500 votes, while Marga received 3,500 votes. So what is the ratio of Cassie's votes against Marga's votes? So in this problem, we have a given. So we have votes for Cassie and Marga. So for Cassie, we have 5,500 votes, and for Marga, we have 3,500 votes. So in this problem, we are looking for the ratio. So find R. So here is our solution. So our R is equals to, so it says ratio of Cassie's votes against Marga. So Cassie over Marga, or in odd notation, it's C is to M. So we have votes per Cassie, which is 5,500. So let's write it here. So we have R 5,500 votes is to per Marga, we have 3,500 votes. So this is the ratio, or in odd notation, we have 5,500 is to 3,500. So we have here the ratio, and we can simplify it in or reduce it in lowest term. So how can we do that? We can divide both numerator and denominator by 500, since 5,500 and 3,500 are both divisible by 500. So 5,500 divided by 500, we have equals to 11. 3,500 divided by 500, we have equals to 7. So our ratio is 11 is to 7, or in odd notation, we have 11 is to 7. So this is the ratio of Cassie's votes against or over Marga's votes. So in this third problem, we have in a public senior high school, SHS, in Caloocan, there are 284 male students and 318 female students. So we are looking for letter A. What is the ratio of the number of male students to the number of female students? Letter B. What is the ratio of female students to the total number of students? So let's have first the given values. So our given value are, so let's notate the male students with M. So we have 284 students per male. And for female, we have 318 students. So the total number of students, so when we get, that is M plus F equals to 284 plus 318 we have equals to 602 students. So we have a total of 602. So first, we are looking for letter A, the ratio of male to female. So for letter B, we are looking for the ratio of female to the total number of students. So for letter A, let's have the solution. So for letter A, our M is to F is 284 is to 318. So let's write it in fractional notation. So 284 over 318. So let's get the simplified form or simplest form. So divide both 2. So their common divisor is 2. So we have 284 divided by 2, that is equals to 142. 318 divided by 2, that is equals to 159. So our M is to F, or the male student, the number of male students to the ratio of the number of male students to the number of female students is 142 is to 159. So for letter B, we have F is to T. So we already computed for the value of the total students, or the total number of students rather, which is 602. So let's substitute the female first, which is 318 is to 602. So let's write again in fractional notation. So 318 over 602. So what is the common divisor? We have 2. So 2 over 2, which is also equals to 1. So 318 divided by 2, again, that is equals to 159 is to 602 divided by 2, that is 301. So as we can see, this is the simplest form. So meaning the GCF is 1. So we don't have any more divisor to be divided in the numerator and denominator. So our ratio for female students to the total number of students is 159 is to 301. So this is our ratio. So now let us have this fourth problem regarding or involving ratio. So we have Ding Dong works 9 days in a month, while Marian works 3 weeks in a month. What is the ratio of the number of days that Marian works as compared with the number of days that Ding Dong works? So let's have the solution in finding the ratio of the number of days that Marian works as compared with the number of days that Ding Dong works. So our given here for Marian, so let's denote, let's use M for Marian. We have 3 weeks, and for Ding Dong we have 9 days. So to get the ratio, of course, we need to first make sure that the two value is have the same unit of measure. So for Marian, we have 3 weeks, and for Ding Dong, we have 9 days. So we are looking for the ratio of the number of days. So we need to convert first this the given for Marian, which is 3 weeks, to number of days. So in 3 weeks, so we have for 3 weeks, we need to convert it, that multiply in every week. So we're converting it in days. So we have, in 1 week, we have 7 days. So multiplied by 7 over 1. So we have weeks over weeks, that is, should be cancelled because that is equals to 1. So 3 times 7 days, we have 21 days. So for Marian, we have equals to 21 days. So to get the ratio, we have for Ding Dong and Marian. Ding Dong is to Marian for the number of days for Ding Dong compared to Marian. So we have 9 days over 21 days. So we have 2, so we can cancel the day to get the ratio. So we have equals to 9 over 21, or 9 is to 21. So to simplify it, we can divide numerator and denominator with 3. So divide 9 divided by 3, that is equals to 3. 21 divided by 3, that is equals to 7. This means that our ratio for the number of days that Marian works compared to number of days that Ding Dong works is 3 is to 7. So there are this also means that the number of days Marian works is 3 over 7 times the number of days Ding Dong works. So Marian works more days than Ding Dong. So this is our ratio. So it's also equivalent to 3 over 7. Last problem for ratio, we have example 5. A car traveled a distance of 120 km or kilometer in 2 hours. So we have what is the unit rate when comparing the distance traveled by a car to the time it takes to cover that distance. So we have here given values. The distance that the car traveled is equivalent. So let's have D for distance. So equals to 120 kilometers. So for the time, time it takes to travel this 120 kilometers is equivalent to 2 hours. So we are looking for the unit rate. So simply the ratio comparing the distance to the time it takes to cover or travel the 120 kilometer. So find D over T. So this unit rate or the ratio, or simply in physics, this is the speed of the car, or the formula for speed. So unit rate again is D over T. So for the solution, we need to substitute the values for our d and t, or the distance and time. So we have 120 kilometers over 2 hours, or 120 km over 2 HRS. So to get the simplest form, we can divide both sides to 2. So they are divisible, or the GC is 2. So we have 120 kilometer divided 2, that is 60 kilometer. Then 2 hours divided 2, that is 1 hour. And our unit rate, or the rate, comparing the distance traveled by the car and the time it takes to cover the distance, is 60 is to 1, 60 km per 1 hour. So 60 is to 1. That's it for the problems involving ratios.